Sorry, working so much. The cats have no attention. All right, so what we were talking about was nesting our for loops and if statements and whatnot, and we could have infinite nesting. So let's say, well, rather than rows, let's say, let's call it stars for now, okay? And we're gonna rename it afterwards. So right now, if I wanted to print stars, here I would be printing, let's say, 10, right? If I run my application. And in this case, it's going to become something linear, uh, where you see here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We started at 0, we're ending at 9. So 10 amount of stars. And in this case, it's linear. What if I wanted to make it into a square shape, let's say? Then we could change this to our rows, to how many rows we have. And inside our rows, we create another for loop, which is the amount of stars that we want to print. So in this case, I'm going to create a 4x4. Sorry, a 4x4. I'm going to create a square star-shaped thing. And by the way, if you don't put the curly braces, it would accept the next statement as the body, and only one statement. But in this case, I like to always put them. Why not? It might look good not to have them, but you could make mistakes, especially when you're a beginner. It's not worth it. So in this case, we're going to create a square. You notice, actually, we're not going to create a square, but we're going to create non-stop stars for the amount of 10 times 10. This is the amount of stars. So there's 100 stars there. The problem is, when it goes inside here, we never go to the next line. So right after this for loop, which prints the stars, we're going to put out a Println. And nothing inside the Println. All we want is just to go to the next line. So now if we look, we have 1, 2, 3. Actually, let me show you. Well, the code is still being shown. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 10 rows, we have 10 columns, which is basically 10 stars. And what you got to understand, again, it's because inside that for loop, this inner for loop must finish before it goes to printing the next line. And when this is done, the rows will increment, and then it's going to restart everything in the body. And this is important because we could have a infinite we could have an infinite nesting of any sorts. Just here I have the same variable names. Let's name it something else. I'm just doing a quick refactor. Refactor just means I'm changing the names. So here, if we look at it, it's trying to do some funky things, which is basically gonna print out 10 times 10 times 10 times 10. A lot of numbers, like 1,000 stars for every row. Because look, the Println is after all of this. So if we print this again, it's really funky, too weird. So you see that. It's still 10 rows because our Println is only happening 10 times. But all those inner loops are happening many times. And then this is maybe not something you would ever do, but these inner for loops, these nested for loops or if statements, you could have had an if statement there, could be used to for whatever usage you want. So one of the good examples would be, what if I wanted to draw something funky? Let's say I wanted to draw stars, but before the stars, let's do something interesting. I wanted to have some space. How many spaces? Let's say I want to have less than rows, whatever rows is. And make it space plus plus, actually plus space. And inside that, we're gonna just do a normal space. Now, if you look, what happens here is, for each row, I want to draw some spaces. How many spaces will be dependent on my rows? And afterwards, I want to draw some stars. And let's see what happens. Actually, you know what? Before we do that, I want to change it a bit. Let's say minus rows here. So we're kind of making it funky. But now you're going to see the shape that's going to come out is going to be interesting. Look what the shape is. Right? If you notice at the beginning, our space and rows equals to each other. So at the beginning, it's not printing any space. But as we go down, as the rows get increased, the amount of spaces gets more, and the amount of stars get less because we're doing minus rows, to eventually have no stars and all spaces. Right? So this, this is pretty cool if you wanted to create this. If you guys have some interest, maybe you could do the inverse of this. Maybe you could do a star-shaped star, right? There's a lot of variations you could do. If you could think of it, the more you understand this, the more easier you'll have of a time to create these types of shapes. And this is important because depending on the array, what type of array you have, you'll notice that a lot of times you have to nest and do weird, funky shenanigans to it to be able to iterate or do whatever you want to do. So, any questions about this? Okay. Well, that's that. So we answered loops. So remember, for if statements, switches, and loops, you could have as many nested ifs, switches, loops as you want. So I'll put that nested infinity. Okay, you keep on going. There is an edge to this, but you don't need to know it right now. It's perfectly fine. Another thing we want to maybe tackle is called a ternary operator. And what's interesting about ternary operator, it's when you just want to set the value to either this or that based off something else. So basically you would have a variable, let's say, let's give you an example, Boolean, am I happy? Sorry. So am I happy, the value, the initial value is going to be based off if outside is blue or not. So outside, does it equal to blue, let's say, right? And it's like an if statement. This part is your if statement. If this is true, do something. If it's false, do something else. So this would be the question, the Boolean question. So I put a question mark, and then the first part is if it's true, what would you like to say? Well, if it's true, I am happy. And then you put a colon to say if it's false, what would happen? So if it's false, we'd say that, right? So am I happy? Well, it depends. Is outside blue? Well, I look outside, it's a nice sky, so yes, I'm happy. So it goes to the first one. Otherwise, it goes to the false. So let's try an example here too. Let's make it a bit more interesting. So I don't know. Let's say the guy's name. So who is listening? I don't know. As an example. So let's make it a bit easier. So who is listening? If the age is under 18, then the answer would be underaged. Underage young one, underage kid, okay? And if he's not 18 or less, so he's either equal to 18 or higher, then it would be a adult. Right? And we have a warning that condition age is always going to be true because we set the value and we never really change it. But here, this part, this is a ternary operator. Ternary operator, yeah. It's the same thing as saying, I'm going to make an if statement, age is less than 18. Then inside the true statement, I'm going to say who is listening equals to underage kid, else who is listening equals to adult. right? So this is the same exact thing. This is a ternary operator into its if statement value. Notice that with if statements, I need to declare the variable outside of these blocks. Why? Because it wouldn't be seen otherwise. There's something called the scope, the age, and we're gonna talk about that as soon as we get to functions. But yeah, any questions about ternary? I'm pretty sure you've seen it. Okay, so we're all good with this. Give me just a second to see if there's anything else I wanted to go over with you guys. Otherwise, we'll start with functions. Okay, I think this is fine. So if you have a question, this the moment. Otherwise, we're moving on to functions. If I missed something, or if you want me to go over something I missed or something again, let me know as well. It'd be my pleasure. You guys listening to me talk all day is what I enjoy the most. Cool. So let's get to creating functions. Now, still within the class, okay? Still in the body of the class. We always need to be inside this body, and you could see this line that shows you where this body is, right? Still within this, we want to create these things we call functions. So I could create it before it or after, it doesn't matter. And unlike C++, I don't need to have a prototype mentioning that there is such a function. Again, Java is a higher level language. We wouldn't really need to do that. Okay? So, give me 1 second. Just want to take out something. One second, guys. Okay. So, a function is going to be a bit important for us. To be honest, we don't need functions or things called methods, okay? Again, functions and methods, the same thing. Actually, I think I already have a line for this. Let's go up. So functions and method, we don't need to really have them, to be honest. We could make all our script inside the void main that we saw, the entry point to our application. There is no reason that we need to have a function. And this is true. The computer really doesn't care. When it compiles this to zeros and ones, it does not have anything called function. That does not exist. Okay? What is functions is for our visual seeing, or for our pleasure, or the human pleasure, to make our life much easier. And in functions, we use it for a couple of things. The first thing, and you're gonna see what I mean, why the computer doesn't care for it. So functions methods, it's something to do, and usually this thing is gonna be a repetition. Well, not always, but it's gonna be. So let's say purpose. If we have to use a sort of action multiple times, so this could go into a function, so we could call the same action multiple times. So a multiple statements into one. It cleans out our code where we could just read one action word which says what it's gonna do. A good example of this is the print, right? I'm gonna talk about that. So actually, just to say reusability, readability. These are the main purpose of a function. Reusability, readability. And when we get to classes, this would allow us to also call on specific actions for that object, and we'll go with this. So it's reusable, yes. It's readable, yes. And also it's going to be the purpose of what it needs to do. Purpose done specifically or something. It doesn't have to check 100 things, etc., etc. We'll come to that in a second. So first of all, you've been using functions a bunch of time. Your entry point to your application is this thing we call a function, the function main, and one that's been reserved. You've been using function all the times you've seen a parentheses like this one, where we have a println. If you hold down Control, CTRL on your keyboard and click on println, you would go to the function code of println, and you notice it's doing a lot of stuff. It's println, notice it's printing and then casting a new line. So this is an interesting thing to do. So if we go again in the print, you'll notice it's using right, and if we go inside the right, you'll notice a bunch of this, and if we keep on going down the line, you'll see it's gonna get more and more complicated, right? To make sure that our code, they could have wrote everything inside this one right. To make sure our code is not so funky, like this is almost unreadable, we want to group them and keep on abstracting the information to something that's more readable. We're trying to bring it to the human language. This is why you kept seeing all of these different functions as we went up. Notice how more English this right became, right? Look at this. This is the lowest as we could, well, we could probably go lower, but this is super hard to read, right? And most of you are looking at this baffled, what the hell is going on, etc. But then we come down to this right over here, which is one level higher. You'll notice it's actually a bit more readable. So the text we get, we have this output the text, we output that string, we flush the buffer for this and that, and blah, blah, blah. And again, if we go even higher, so let's say println, it's much easier. What it's doing is printing and then the new line. And if we go inside the print, we notice it's just writing the value of that string, etc., etc. Cool? So, readability, again. Reusability. Notice we're calling println multiple times. And what's really funky is, actually I'll post that in a second. Let's go ahead and create a function and we'll explain what the funky part is. To create a function, you need a couple of things. The first thing is, not in every language, actually even in Java you don't need, you have the option, I'm going to put it inside these little things, to give the accessor. It's an option thing, but you should always do it. If you don't do it, I'm going to give you 0 because this is for readability and improving your code. So you need to give the accessor. You have, this one is an option. You have the choice of saying if it's static or it's not, right? If there's nothing, you don't say it. You have to say the return type. You have to say the name. Actually, these are not, they're not optional. You have to also say the name of your function, a unique name. This is a bit interesting because you'll notice that we don't actually need it to be unique, but we need it kind of unique. You're going to see it in a second. And a bunch of parameters with 0 to many types of things sent there. So this is parameters and their types. Okay? And obviously, you'll also need to define the body inside of that. So let's go see this. The first thing you need to understand, let me crack my back a bit. The first thing you need to understand, there's this thing called a function signature, and this is important. A function signature needs to be unique at all times. And inside the function signature, based on the language you use, it's going to be a bit different. Inside Java, the function signature is based on the name of the function, so the function name, plus the parameter types. And this is important. Not the parameter names, it doesn't care for that, but the parameter types. And we're going to come back to this function signature in a second. Okay, but that function signature is the function name and the parameter type. In other languages, the return type is also included. So let's go ahead and create us a function. So let's say the system.println, it's a pain in the butt. I don't like to read this. I want something more cleaner. So what I would do is I would create a public. So we have to mention the accessory. If we don't, it's gonna use the default, and the default is package. Again, we don't wanna rely on defaults. Defaults change based on language, based on other stuff. So here we wanna put public. For now, we wanna put static. I'll explain static a bit later. Then we need the return type. So in this case, void, we wanna print the screen. I'll explain that in a second. And let's call it print. And inside print, it's gonna take a string, let's say the message you wanna pass in. And inside that, we're gonna say cout string, right? So now wherever I use print, system.out, they're all printlns. Well, anyway, okay, over here. Well, now I could just say print. Isn't that cleaner? Right? And again, every time we run something, make sure to run it once, make sure it works. So over here, what is your name? What is your name? So it works. Right? Now let's do the same thing for println. So again, I'm just gonna, well actually, let's write it down. So public, static, void, println. I'm gonna capitalize the last part. Maybe not. I'll keep it with the standard that we see here. And again, it's gonna take a string. And all it's gonna be doing is printing it. And then now look at this. I could come here, the system.out, I don't need it. System.out, I don't need it. System.out. Do I need it? Uh-oh. System.out. What's going on? Now, our functions are becoming shorter. Here it works out perfectly. Same thing as our print. And the only thing we did was redirected, reworded. And this is perfectly fine use of functions. It allows our code to be more readable. And that's our early stage goal, to make our code more readable. And the more readable it is, when we come back to it, the more we're gonna be able to understand what happened. If we made a code 2 months later, 2 months ago, it becomes kind of foggy in our mind. I don't remember what I was doing. So you start reading your functions, your names, your code to see how much sense you could get out of it. I hope I'm not talking for myself. If you guys are not listening, I'll just stop, by the way. Anyway, I'll continue. I saw a few of you guys turn on your mic. Thank you for being there. So now, even though we cleaned it up and we made our code a bit sexier or a bit more beautiful, we still get this error where it says the parameters, this is what we pass to our function. The parameters over here requires a string, but we passed it a float. Okay, so let's talk about this. So inside of a function, there's always three major important things. Usually, like when you use println, the name of the function tells you what that function is gonna do. And again, we don't want our function to do anything more or less from the name that we gave it. So if it says print, it will just print. It won't go ahead and create variables, do weird stuff, go make my taxes. It won't do those stuff. It will just print. Now, for it to be able to print, it requires something. That's where the parameters come in. The parameters are declaring variables to be filled by the caller. So in this case, println requires to pass hello world, the value, and that value is going to be inserted into s, this variable type that I declared here. I don't need to redeclare it. So this s is existing, right? It's going to equal whatever is being passed inside the parameter. So the name tells us what it's going to do. The parameter is the requirements for it to do that thing. And the return type is kind of like a contract saying what's going to be given back if there is anything. so I could expect something or not expect something. And in this case, we see that it's being said void, where there's no real type. Void means like the galaxy, it's empty, there's nothing there, right? A good example of this would be if you go to McDonald's. You go to McDonald's, uh, you'll see a lot of red here, but it'll make sense. When you go to McDonald's, you want to order your food. So the name of your function is going to be order food, right? When you order your food, what do they need for them to be able to accomplish your demand? Think about it for a second. If you go to McDonald's, what do they need for them to make your food? Well, for one, they need to have your order. If they don't know what you want, how would they do this? So let's say it's a string for now. So string your order. And whenever you give an order, well, obviously you got to pay the guy, otherwise he wouldn't agree with your order. And another thing would be you need to give him money. So that's the price, right? That's the money for that order. These two things are required for you to order food, for them to accomplish what needs to be done. Now, when they accomplish what they need to be done, what are they giving back to whoever called them? What are they giving back to the person that ordered food? Well, they're gonna give them their food, right? So let's say this type that doesn't exist yet. So this food is gonna be given back to whoever calls order food with the specific order and the money. Notice that to be honest, we don't care how it does it inside the function, inside the body. What we're expecting or what we're assuming is we're assuming the guy who coded this, he coded it perfectly. There's no mistakes, and if there was, he dealt with it, and if there's new mistakes, he'll deal with it. But I always know that whenever I order food, they require an order and they require money. And if they got those two things, they're gonna give me back my food. Does that make sense to everyone? So inside the print in the println, actually let me make sure that because I'm not sure if I'm hearing you guys. Okay, good. So in the case of my println, I don't need anything back from it. What it needs to do is to print to the screen. So I don't need any values back, right? If we look at our scanner in that case though, our scanner over here, I need a value back. So this next line, if we actually go to it, notice that next line is returning a string. It doesn't require anything. That's because it goes and fetch from the console itself, right? So let's go back. So now knowing that print and println requires a string to be able to print, what should I do for this where it has a float and a string or a double? Well, one thing we could do obviously is we could typecast it, string, or let's say value of, and give it money. This is one way to typecast something. The string.value of, we'll talk about it a bit later. Another thing we could do is to overload a function name. So we said it has to have a unique function name, but actually what it needs to be unique is the function signature. And why I mean this is because the computer needs to understand which prints to do, right? So let's give an example here. For this println, we're taking a float, but over here we're taking a string. So what I'm gonna do is public static void println, but rather than giving it a string, let's give it a string for a second. It's the same code as the other one. You'll notice here it's gonna give me an error saying, hey, I already declared this one. Again, the computer's stupid. It can't figure out if I need to use this or this, right? Because in his view, the two functions look alike. So which one should it use? Well, in this case, we want to print a floating number. So the type here, we're going to change. So now the signature is changed. Remember, the signature in Java is the function name. It has to be the same. So this is same. Well, sorry, it has to be, one of these has to be unique, okay? In this case, they have the same name, but the parameter type, not the name doesn't matter. The type is different. Does that make sense? And you'll notice that now our float money doesn't have an error, and our curve will need to do the same thing for double. And based on the parameter, based on the function signature, it'll know which function to correctly call and execute. And this is called function overloading. So they have the same name, but the function signature is different. And this is an important aspect of programming. And you've been using it forever. Notice here, when we call those printlns, actually, let me just do one of these printlns. Notice this println and this println, this println. Or actually, let me do something else. Notice all of this IntelliSense showing you. You'll see that the parameter inside is int, character, long, float, character, array, double, string, boolean, object, blah, blah, blah. And the return type is always the same, void. These are all different functions that have been overloaded. And you've been using it for ages. Actually, let me control, I'm going to hold down control, click. This is println using a string, println using an object, print, if there's another one, I don't know, let's go up, println using character array, etc., etc. And they're calling, again, an overloaded function, which is print. Look here, print with character array, print with string, which is basically converting it to character array, in my opinion. You see all of them is like string, right? And again, we do this because println, the word, the action, the name, says it all. And it'd be stupid to say print string line, right? And then you have another one which is print float line. The names become too much for doing the same action. So overloading allows us to make it a bit more readable and more reusable than having 100 different names for doing the same action. Any questions about functions and overloading? Okay, so that's that. So let's say another one. Let's say another one here, and this time let's return a value. Oops. So public static. Let's say this time we want to get something that does the power, right? In the case of power, we're going to be retrieving an integer. Let's say power. My power is fine. And then we need two things to get the power. We need first the int, which is the base. Secondly, we need the power of, right? I don't know what they call this, but I'm going to say power here. So having the base to the power, we could figure out the value. So give you an example, 2, or let's say 2 to the power of 3 is basically equal to 2 times 2 times 2, right? This is what we're trying to create. So now you'll notice we're getting an error. If we look at that little red squiggly line here and we put our mouse over it, or we could see the red on the right, it's telling you it's missing a return statement. Here we promised that we're going to give something back. We're going to give back an integer, but we never gave back anything. And this is done with the keyword return. The moment we type return, we're giving back to whoever called us a value. And you're going to see that in a second. Well, we're going to call it in a bit, okay? And again, notice that when it's gray, it means it's not being used. Notice here it's yellow, here is gray. Some things to note about return. The moment a return is hit, return ends your function. A good example of this is, look at here, inside void main, I could also do a return, which I'm not returning anything because it's void, but as soon as I do that, everything after line 124 is not reachable, and you might get errors based on your IDE. Some IDEs will even let you do it. So here you're seeing it says unreachable statement. So you could never reach this part because the moment it hits a return, this function has been ended. And if this function ended, it means your application has finished. Okay? Again, stop me anytime. So in this case, whenever we see a return, it's done. So a good example of when we should do a return quickly. Well, actually, let's first build this, okay? So in this case, we want a for loop, which is gonna be, it's gonna go into an iteration. We could just write x in this case, starting at 0, x is smaller than power. I'm really tired of talking. And in this case, we want an int total, which starts at 1, let's say, or the base. No, we want the base. So in this case, what we want to do for each iteration, we want the total times the base. Total equals total times base. By the way, this, we could also write it like this. Total times multiply equals base. It's the same exact thing, okay? That's why I left it in comments. Whatever is easier for you to read. Again, readability is over everything. So for each number, we want to do that. And when the loop is done, we want to return our total. Now, I don't have a calculator on this computer, but if we do 0 to the power of 1, we get the value of 0, right? 0 to the power of 6, it's still going to give us, okay, let's do 0 to the power of 6, it's going to give us still 0. So if the base is 0, we don't need to do any for loops, it's already done. This is important because it makes our code a bit faster. If he does 100,000 loops just because the power is 1 million but the base is 0, then it'd be kind of stupid, right? So something we could do is say if the base equals 0, then just return 0. We don't care, right? And notice, because we hit the return, all of this will be ignored. And because it's inside of an if statement, it's only if base equals 0. Any other cases, it will not do this. Cool? Now again, if you have questions, be my guest. So let's, as always, when we do a code, we want to test it out. Always do it step by step. Test your code. Don't wait till you write 1,000 lines. So in this case, I created a function. I'm just going to do it at the beginning. So let's say I call power, and I give it a base. Let's say the base is 1, and we're going to set the power to 100. Okay? Now, if I run this, even though I'm calling that function, notice it's still printing hello world. The problem is, and we get a warning for it, is we're not doing anything with the result, right? Result of power is ignored, right? This is why a good IDE is amazing. It gives us hints, ideas, errors, explains it to us. The better he explains, the easier time we'll have. So even though I'm getting this value, I'm not doing anything. I could store it into something. So let's say int a equals power. I could also output it to the screen by doing this, right? This println, well, it's like math. You have to do the stuff inside the parentheses before you could do the outside stuff. So this power thing must be finished. Then it will print it to the screen. Let's run it. Stop and run, blah, blah. So you notice the power of 1 is always going to be 1. So this is, again, a useless loop. So here we could say if base is also 1, well, don't return 0, but return the base, whatever the base is. now our speed of our application gets faster because 0 and 1 are meaningless. So 1, perfect. Let's do this line again one more time, one more time, one more time. So we check, let's check for 0, let's check for 1, let's check for 2, let's check for 5. And you notice we get 0, 1, 0, and oh shit, what happened here? So, who could explain me why do I have this? I can't hear anything. Give me a second. I think my microphone is broken. Realtek. Can you talk, Armand Preet? I couldn't hear you. No, still can't hear you. One more time. Did I mute? No, it's... 1 second. I can't hear anything. Try again.
So I think it's out of capacity to store of a variable.
Perfect. So this number, so this is what's so interesting, okay? So again, remember that all of this gets translated to ones and zeros, right? To the machine level bits. And inside there, there's really nothing that's multiplication. That doesn't even exist. What they do is they move around bits and do funky stuff with it to replicate a multiplication or create any funky stuff that you've seen or done so far. And what's so interesting is our total is currently integers, right? And if we saw integers are, well, when we heard, you shouldn't believe everything I say, do your little search on your own. Integers are 4 bytes. Now, this 4 bytes means, every byte is 8 bits, right? And every bit is a 0 or 1, right? So let's go in here. So 4 bytes means basically we have this. And 1, 2, 3, 4. And this is one integer. All these zeros and ones, this sequence together is an integer. And at the beginning of this integer, they use the first bit, or however they did it, they might do it differently. They use the first bit, 0 for positive numbers, or 1 for negative numbers. So they actually lost 1 bit for the amount of size as well. And we could talk about that, but it's not the point right now. And if you don't know how this works, again, the amounts of zeros and ones, the bits are used as a sequence to represent a number. So in this case, all of them off is equal to 0. If I turn on the first bit, then it equals to 1. Then if I can't put any 2's there or 3's there, so if I add one more, this becomes 2, so it'll go to the next place, and this becomes 0. So this is 2, right? Keep on going. Now, the problem is, at some point, the number became too high. So remember, this is to the power of 2. So 4 bytes, actually, we could do a quick Google search here. We're talking about Java int max size, okay? So the max size, actually we have it right here. I don't want to look into this more. So the max size with 4 bytes, these are the max size. And you'll notice there's a 1 extra inside the negative, and that's because of the bits that's lost. But this is another talk for another day. Now, when we reach our maximum size and we try to add or multiply more, and again, multiplication doesn't exist, it's trying to shift bits to create the multiplication. And I'm not going to go into the details of how to do that, otherwise already we're behind schedule. As soon as it tries to shift the bits, this number already reached the maximum, and it fucked up because the bits got shifted and there's like something missing because it doesn't have more bit size. byte size or bit size, whatever you want to call it. And because of that, for some odd reason, this last bit that we're talking about, this reserved bit, which was for negative, which was negative if it's 1, positive if it's 0, got turned into 1. And that's why you see this. And all the other bits got also shifted, so you see a random value, which was by luck. Well, not by luck. If we do this 5 to the power of 100, you always see this. But if I do this 6, and let's make this one, actually, copy, paste there one more time. Let's say 5. And you see 6. Because of the shifting, again, you'll see something different, right? So let's go back now. So in this case, we got to 0. If there is any fix or whatever, shit happened. Basically that. Okay, so this is really important to figure out how big our power could go to. So if we needed to do something, we could check if it goes higher than our max value, and if it does, we give out this thing we call an exception error. And how should we know what our max value is? This is because we're inside of a higher level language. We don't actually need to memorize these numbers and whatnot. It's good. It gives you a bit of more insight, and the more insight you have, a bit more power you have over the language. But what we could use is this helper class. So the next thing I want to add is helper classes. These helper classes are objects that we're going to talk about soon, or whatever you want to call it. There's these objects that are there to help you with certain tasks. And all of these objects, there's a lot of built-in ones, such as string, such as int, capital int, notice that, capital double, capital blah blah blah. They're all of them, all the primitive types. There is a helper class built with it, which is capitalized. So what I mean by this, if we come back here and this, so we have to do, okay, so the thing is I need to change the int here. Let's change it for a long, okay, and then we'll typecast it to an int. Okay, this long is actually 8 bytes, so now it could store a bigger number. Are we clear with that? Now the thing we need to do is check if our current total, which is a long, which is much bigger, as an example, is bigger than int. So integer helper class is there. You see capital I brings it up, use the IntelliSense. Integer dot. And now we have a lot of functionalities that helps us do things. And if we go through all of this, you'll notice there is a couple, sorry, I'm really tired, a couple variables, static variables, that's always going to be the same. And you'll notice there's a max value and minimum value, right? And you notice it's in hexadecimal types. So anyway, we're going to say if the total is bigger than integer max value, well, here we got an error. For now, we don't know how to do errors, so we're going to just return -1. Else, if this is not true, remember that return ends our function, then it's going to return the total converted into an integer. Does this make sense to people? So now, you should see that this one actually didn't do what we were expecting. Total is bigger than, so why is it not giving it there? I guess we also went over we also went over the amount allowed inside long. Let's do something big integer. I don't want to go so far. No, okay, we're gonna ignore all of this, okay? But just understand that this integer max value is a helper class that allows us to it helps us, like knowing what's the maximum numbers that integers go to. It helps us by allowing us to convert things, to compare things, to whatever all of this is. Get integer from a string, get the hash code, the maximum out of these two numbers, which one's bigger, etc., etc. And this could be really interesting, right? So like, what is the highest one bit? What is the lowest one bit? These are the values that we're looking for, the highest and the lowest, right? And as you go further along the route of programming, you'll see that knowing that these things are there and available, you could make really funky stuff, and that's the cool part, the really really interesting part. Right now, beginning stuff is really boring. Um, but yeah, I'm not gonna go too much into this further. To fix this, yeah, it's not worth it. Okay. Any other questions? To fix it, it's not worth it. If you want to fix it, we could do it in a different time. So that's for functions. We did overloading. Okay. Does anyone have any questions? The next thing is to create a class. And to be honest, I think we're gonna do that tomorrow because I'm out of energy talking all day. Okay, let me just see in my list if there was something I did not cover. Yeah, so I think we're good. Tomorrow we'll continue with classes. Um, However, I do have a work for you, especially now that we have 2 hours left. Let's go into. Actually, I'm going to stop the stream.